In the second half of this video, we're going to look at how to write a quadratic model for a sequence. So a quadratic model is going to be an equation that's going to be quadratic, right? So something squared plus a linear term for n plus a constant, right? So it looks something like this. Our goal is to find the equation, but know that the equation is going to be quadratic instead of linear. So this is the formula that we're kind of looking to get. And the way that we're going to get that is by finding something called second differences. So first, I'm going to look for first differences. That's how far apart all the terms are. And we've done this before, right? So the differences are 5, 7, 9, 11, and 13. But then we're going to look at something called second differences. Second differences are when you look at how far apart the first differences are. 5 to 7 is 2, 7 to 9 is 2, 9 to 11 is 2, 11 to 13 is 2. Once you notice that all the second differences are the same, that's how you know that a model is quadratic. To find the leading coefficient of the quadratic A, you take the second differences and you divide it by 2. So in this case, since my second difference was 2, 2 divided by 2 is 1. That means the leading coefficient of my equation is definitely 1. 1 n squared plus bn plus c. Now I just have to figure out this part. I already know that the leading coefficient is 1. So since we know that this starts off as a sub n equals 1n squared, let's make a function for it. A sub n equals 1n squared. So let's plug in the different values for the terms. So like 1, 2, 3, 4, 5. If you plug in 1, 2, 3, 4, and 5 into 1n squared, you get 1, 4, 9, 16, and 25. What we're going to do is we're going to subtract these quadratic terms from our original terms in our problem. Our original terms in our problem were 0, 5, 12, 21, and 32. And we're going to look at what's left over. And that's going to give us 0 minus 1 is minus 1, 5 minus 1 is 1, 12 minus 9 is 3, 21 minus 16 is 5, and 32 minus 25 is 7. This guy is a linear or arithmetic sequence. Now that we know that this sequence is arithmetic, all we have to do is apply our nth term formula to it, and that should give us the rest of the formula that we're looking for. So here's my A1. So A sub n is A1 plus n minus 1 times d. Right? What do you notice about d? Well, it's 2. So let's simplify this expression. We get A sub n equals 2n minus 3. So this guy and this guy are going to work together to form the entire formula for my quadratic sequence. So it's going to be A sub n equals n squared plus 2n minus 3. And that's my formula. All right, so this is the time for you to try it on your own. So remember, you need to find first differences and then second differences. Cut your second differences in half to find your leading coefficient. What's interesting about your choices here as multiple choice problems is that the leading coefficients are all different, which means once you find the leading coefficient, you're pretty much going to know which one of these is the answer. So pause the video and take a look at it now, and when you're ready, resume the video and check your work. You should have found that the correct answer was B, 2n squared minus 2n plus 10. So this is when we're going to be looking at summation formulas. we'll be primarily using this summation formula. The only time that we ever have to use this summation formula is if you don't know a sub n and you have to replace it with a1 plus n minus 1 times d. And sometimes you have to do that, and then the formula will look like the second one. So find the sum of the following sequence turned into a series. So we might notice a couple of important things, like we know a1 and we know d equals 5. What we don't know is we don't know what term number this is. We don't know what the last term is. We actually don't have to know what that last term is. We just have to know what the value is to plug it into our formula. So let's plug all these in. All right, we're going to plug in our nth term formula. We're going to plug in 157, and we can figure out what this is for n. So this is 157. I know a1 was -3. And of course d was equal to 5. If I keep solving this for n, I'll find out that this is actually the 33rd term. And that's going to be important to me because I'm going to need to plug that n in right here into my summation formula. So now that I know I have 33 terms, I can plug in the first term, the last term, and the number of terms into my summation formula. So I plugged in the number of terms here for n. I plugged in the first term, -3, here for a1. And I plugged in the last term, a of 33, in here. And I'm going to simplify this, and I get s of 33. In other words, the sum of the first 33 terms equals 2,541. Let's take a look at another example. This one says, find the 17th partial sum of the arithmetic series. So notice that here's a1, here's a2, here's a3. They actually don't find a17 for me, so I'm going to have to do that. One of the other things that I can do is I can substitute in for a17 the formula a1 plus n minus 1 times d, where n is going to be 17. And then d, it looks like it's pretty easy to find in this case. It looks like the common difference between the terms is -22. So I can also plug that in to my formula. So here's my arithmetic sum formula. I know that I have 17 terms. That's my n. And I know what a1 is. a1 is 53. And I know what d is. d is 22. And I know that n is 17 because I have 17 terms. So when I simplify this formula, I found that the partial sum of the first 17 terms, or s sub 17, equals -2,091. Here's another summation. This one looks a little bit different. This one is using sigma notation. Remember that when we use sigma notation, this guy right here is the formula that I am plugging things into. This is the first thing that I plug in, and this is the last thing that I plug in. So if I just start looking at this, plugging in n equals 10 gives me a1, n equals 11 gives me a2. I don't need to find all of them because plugging in n equals 32 gives me a of 32. What I need in my formula is I need to know the first term, the last term, and the total number of terms. So there's my first term, 16, and there's my last term, 38. So how many terms do I have? Well, if the first term is 16 and the last term is 38, and I started with 10 and I ended with 32, that means there's a total of 32 minus 10 plus 1, or 23 total terms. You can count them out on your fingers if you want to, but the general rule is you take the first, you subtract the last, and then you add 1 back on. So now I have all the important information that I need to plug into my summation formula. I have n, I have a1, and I have a sub n. I'm going to plug those into my formula. And when I simplify, I find that the partial sum of the first 23 terms equals 621. Now it's your turn to try. Take a look at this sigma notation. It's giving me a sum as n goes from 12 to 40 and the formula to plug it into. So remember, you're going to need to find the total number of terms, the first term, and the last term, and plug them into your summation formula. So do that now, and when you're ready, pause the video and check your work. You should find that the correct answer is B, 2,146. The last problem we're going to look at is a word problem. It's important that we be able to pull out all the pertinent information from our word problem, like the first term, or the last term, or the common difference. In this case, we have an artist receiving royalties for all CDs that are sold. For the first 10,000, he receives 10,000, then he receives 12,500, then he receives 15,000, and so on and so on. So what we want to do is we want to look at these terms and see if we can find the common difference. We also need to know the number of terms in the series. So it says, how much money will he receive if 500,000 CDs are sold? He's being paid for every 10,000. So we need to figure out how many 10,000s are in 500,000, and we do that through division. So now we know that there are n equals 50. There are 50 terms in this sequence. The second thing that we need to know is D, the common difference. So we're looking at the difference between the amount of money he's being paid each time. In other words, what's the difference between 10,000 and 12,500? And between 12,500 and 15,000? And we find that D equals 2,500. In other words, he makes an additional $2,500 for each 10,000 CDs he sells. So here's my formula, right? My formula is going to be plug in n equals 50, the number of terms. I know that A1 is the first amount of money that he gets paid. That's 10,000. Again, n equals 50. I put that here. And then D, the common difference, is 2,500. And I want to simplify this expression. And I'll find that over the total course of his payments, he'll make $3,562,500.